Fume hoods are one of the most important safety features in a research laboratory. The hood is used to protect researchers from breathing hazardous airborne chemicals, and the sash can be used for protective shielding. This presentation demonstrates how to use your fume hood properly to better protect yourself and our environment from exposure to hazardous materials. When you use the hood, you should turn on the hood light so you can see clearly. Check the hood certification sticker. It will list the date EH&S last checked the hood, the average inflow, and whether the airflow was satisfactory. One should always check the quantitative airflow monitor or alarm to verify that airflow for the fume hood is proper.
All fume hoods are required to have an indicator showing if the hood is moving enough air to protect you adequately. There are three basic types of indicators on campus: those with a gauge showing the pressure in the duct, or with an audible and/or visual alarm when the face velocity is too low, or with a digital display of the face velocity, or some combination of these types of indicators. Please familiarize yourself with the flow indicator for your particular hood, and if you see that it is not working, contact physical facilities. If your alarm does go off, if you just lower the sash a bit and hit the reset button, this will generally clear the alarm. But please don't stick a paper clip or piece of tape over the alarm mute button. If lowering the sash does not eliminate the alarm, something is probably wrong with your hood, and you should report it to your department office immediately.
Airflow turbulence at the front edge of the hood can draw airborne contaminants out of the hood. In this case, the sash is too high, and when someone walks by, the low inflow velocity allows the smoke to come out of the fume hood. Adjust the sash to the proper height. In this case, the glass sash was raised to the maximum working height as indicated by the joined arrows, then slightly lowered. The tissue on the sash is drawn in, indicating that there is airflow into the hood. When the sash is lowered, the capture appears better, but when the velocity becomes too fast, research samples can be sucked up the hood duct. Sashes properly adjusted and working further into the hood are the best way to protect yourself from inhaling hazardous chemicals used in the hood. Move extra equipment out of your way and always work at least 6 inches in from the front of the hood.
Large apparatus or clutter inside the hood can obstruct the airflow and allow fumes to escape. Apparatus should be elevated on blocks to allow air to flow under it.
Some hoods have a combination sash that can be opened horizontally or vertically. In this case, the sash is lowered, then a horizontal sash is adjusted to provide protection from explosive reactions or chemical splashes. Typically, there are no pollution control devices on fume hoods. The airborne contaminants made in the laboratory hood are exhausted from the roof stack into the environment. Never evaporate chemical waste through a hood, and when working in the hood, minimize the volatiles released to protect our air quality. When you are done using volatile chemicals, close and seal the container. When finished using the hood, close the sash and turn off the light for added safety and to save energy.
Another type of fume hood that you may encounter in the laboratory is known as a variable air volume VAV fume hood, also known as a constant velocity hood. It is a hood that has been fitted with a face velocity control, which can vary the amount of air exhausted from the fume hood in response to the sash opening to maintain a constant face velocity. This has two important benefits. It can allow for optimum hood performance regardless of the sash position. VAV hoods also provide significant energy savings by reducing the flow rate from the hood when the sash is closed, and in some cases have a motion sensor that detects the presence of a user. It is very important for VAV hood users to keep the sash closed as much as possible while working at the hood, and to close the sash completely when the hood is not in use. This will ensure a safe work environment for all hood users. Another very important characteristic and a benefit of the fume hood sash is that it can act as a barrier protecting the fume hood user from any splashes, flying glassware, and possible fires that can occur in the hood. VAV fume hoods are also equipped with a monitor that indicates whether the hood is in standard operation or standby operation mode. The fume hood monitor also has an emergency purge button, which increases the airflow through the hood to maximum and can be used to quickly remove air contaminants from the lab.
In review, before using the hood, check the airflow monitor. Properly adjust the sash height. Always work at least 6 inches in from the front of the hood. Fume hoods exhaust into the environment. Minimize your fume hood emissions. In closing, if you have questions about your fume hood, ask your lab manager, chemical hygiene officer, department safety coordinator, or contact the Office of Environment, Health, and Safety. Also, read the fume hood fact sheet and other laboratory safety information available at the EH&S website.